Of course, we want to get rid of fractions. Yes. So I'm going to multiply both sides of the first one by, and the second one by. Good. So then I have 3x minus y equals -3. Everyone agrees with the first step? Now, negative x over 2 times 8 will be -4x. Y over 8 times 8 will be plus y, and this will be 2. All I have to do is just add. I get negative x equals -1, so x equals 1. I go back anywhere I want because I'm going to check in the original problem anyway. So let's say I go back here. So I have 3 minus y equals -3. Negative y equals -6, so y equals 6. It appears that the solution is 1, 6. I don't trust it till I go back and check. So I go back, and I have here 1, 6, 1, 6. 1 minus 6 divided by 3, which is 2. 1 minus 2 is -1. Yes. Negative 1/2 plus 6 over 8. Let's see what this is. I simplify. Negative 1/2. I simplify by 2. And I have plus 3/4. The least common denominator is 4. So 3 minus 2 is 1. 1/4. Yes, I will get 1/4. So this must be it. It is the solution. Very good. Any questions? Any questions? Okay. So now we figured out what the question was. So I'm trying to go back for a second. If I remember correctly, let me just go back, because I want you to relate to that. So let me see. When did we do function? We looked at functions. It was previous time. Yes. Okay. So if you remember, we looked at oh no. No, it wasn't last time. Okay, that's 3.6, 3.5. Because I want to relate to what we covered last. Okay. It can be before this one because that was the first class. Oh, I didn't mean that. This is what I meant. Okay. You will see I showed a problem in which we determine the range in the domain. I pressed again the wrong thing. Okay. This is what I want. Okay. I messed up again? Ah, no, I didn't. Here it is. That's the squiggly thing that you're talking about, right? So I cannot present the domain of this in any other way but 1, 2, 4. And if I don't use this, and I use bracket or parentheses, then it means that it includes everything in between, and I can't do that. The same thing with the range. 0, comma, 1, comma, 2, comma, 3. Got it?
So you will leave that in like piecewise.
It's not a piecewise defined function. It's a function defined in points and nothing else. If the points were connected, I would have used either parentheses or brackets. But since the points are not connected, I cannot connect them because I want to connect them. I can't change the graph. This is what I'm given. So that's why in that function you had something like this. Nobody can see, sorry. So you had something like this, right? So this was your function. It may have been in different direction. But anyway, this is at -3 and this is at 9. So that's why your range is only -3, 9. That's why I wanted to relate to that, because I didn't forget to show something similar, because I knew you would encounter something like that, so I didn't want you to be surprised. Good. Perfect. Very good question. So now we know, here's where we are. I would like to go back to graphing piecewise defined functions, so we can choose another problem, and then we're going to look at relationships between variables, and that will be the end of this unit, and we're going to start reviewing today. Okay, the test is a week from today, right? But next Tuesday I'm going to answer your questions, and I have to move on to something else. So bring all your questions between now and Tuesday, finish up everything, make a list of questions, and on Tuesday say, I want to see this. And after I answer your questions, I will have to move on to chapter 9 and then chapter 10. Okay? Chapter 9 is not going to create problems. Chapter 10 is a very long chapter, but I created a handout for you. So we're going to go through the handout and then come back to all the problems in the book. Okay, so I already have it copied for you. Don't copy it. It's up there, I think. I already put it up, but don't copy it. I already have copies for you. Okay. So let's go back to piecewise defined functions. Have you tried them one more time? Have you tried anything? Do you have any questions on anything? Thank you for bringing that question to class. Thank you. Have you tried anything? Any questions? Or we go back to 8.3? Okay, well, you can stop me anytime. So 8.3, back to more piecewise defined functions. Please choose if you want. On page 535, if you have your text, anything you want. From 9 through 16. Or we can make one up if we want to. Let's make one up. So help me make one up. Did I start this or not? No, I did. Yes, I did. Oh, good. Okay, so f of x. Can anyone give us a piecewise defined function? Okay, I'm going to make it up. -2 for x less than or equal to 4. And 2x minus 4 for x greater than or equal to 6. I'm hoping that the next one you will make up for us. Okay? So how do I start? Of course, the question is asking us to graph. What is the first step? When I'm asked to graph a function, I'm given a function to graph, what is the first thing, the first thought that comes to my mind? Excellent. I have to find a domain. Without the domain, I cannot do anything. So obviously, I'm looking at the x values, so I have to identify what this means, and I have to identify what this means. So if I change that into interval notation, what do I write? Assuming I have this inequality and I'm asked to present it in interval notation, how will you write this? Careful. Good. Right? Because it's less than or equal to 4. Good. What about the other one? Excellent. Okay, now let's analyze these two and say, yes, this function has all real numbers, or no, this function has not all real numbers as domain. What do we conclude? Does it or it does not have all real numbers? It does not. So the domain is negative infinity to 4, union 6 to infinity. We all agree with that, right? So then when I create my chart, I have to keep the domain in mind, and of course I'm going to write this. Negative infinity to 4. Of course there is a bracket facing this way under 4. Then I'm going to write 6, and there is a bracket under 6 facing that way, and this is nothing, empty. This function is not defined on all real numbers. There is nothing I can put between 4 and 6. And the brackets are facing opposite. Good. Now, as you already know, I'm going to write in here the function that I have to use for negative infinity to 4. And you will say, yes, it's negative 2. That's it. Now, which function will I use between 6 and infinity? Of course. Very good. Perfect. Okay. So now, let's pick some values. They are both linear. I should have put also some square root, well, maybe absolute value, because we already know those functions yet, but that's fine. So let's say I have to have 0. And when x is 0, how much is y? How much? Correct. When x is 4, how much is y? Of course. The function is negative 2, no matter what. Between negative infinity and 4, the function is negative 2. Perfect. On the other side, I have to plug in 6. What do I get? Perfect. Let's also plug in 7 and see what we get. Very good. That's all I need. They are lines. I don't need more than 2 ordered pairs. So here's the graph. First ordered pair from left to right. Which one will I plot? Perfect. Next ordered pair that I have to plot. Is this a full point or an empty point? Excellent. Next ordered pair, please. Six comma 8. Full point or an empty point? Perfect. And then 7 comma 10. I'm going to say it's up here. We already have the domain, but now I'm going to ask you about the range. So please give me the range of this function. And then you will know why I've chosen it.
-2.
But in this way, union, because it's only one value. It's only this value. And then empty and empty. Union. To infinity. The smallest value is 8. This is right here at 8. Very good. Okay, let's make one up. Just make up another piecewise defined function. Any questions on the one that we just looked at? Okay, let's make one up. Would you like to? Anyone? Or I will copy one.
12.
Let's do 12. Very good. So f of x is 4x minus 4 for x less than 2. And it's negative x plus 1 for x greater than or equal to 2.
Can
you move it up a little bit, please?
Oh, yes, of course. I'm sorry. Sorry about that. Of course, we're asked to graph. When we're asked to graph a function, what is the starting point? Always.
Domain.
Domain. Very good. So I look at what I see here. And let's change this into interval notation, and let's change this into interval notation. For two reasons. One, it's easier to identify the domain, and two, I need those intervals because of the open point and closed point. So the first one in interval notation is excellent, and the other one? Good. Now let's analyze these and say yes, all real numbers, or no, not all real numbers.
All real numbers.
All real numbers, I agree. Because we have everything to the left of 2, we have 2, and we have everything to the right of 2. Awesome. Good. So then, I know what I put in my chart. Negative infinity to infinity, and f of x. No matter which values I pick, I must pick 1 for sure. 2. Very good. And 0 and 2. And look at the symbols underneath. This symbol facing left and this symbol facing right. And they touch. Right, exactly right under 2. Now I'm going to do this. I know it's redundant, but it's safer to do it this way. I accept any method that you are taught by anybody else or the book. So which function I will have to use between negative infinity and 2? Very good. Which function? I know it's redundant and very clear which one, but let me say it again. Which function we use between 2 and infinity? Good. So now let's plug in. They're both linear functions. If I plug in 0, what do I get? Good. If I plug in 1, what do I get? Good. I have to plug in 2. I have no choice. You can say no, 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 because you can't, and I will say yes, because if I don't plug in 2, then I have to plug in 1.99999999999, and I'll plug in 2 and I'll leave it open. If these two numbers are not the same. But if they happen to be the same, then I will fill it in. So what do I have? Good. On the other side, what do I have? The other side of 2? Negative 1. And let's say 3. Negative 2. That's all I need. First order pair from left to right that I need to plot. Perfect. I don't want green. I want anything else. Okay. Good. Next ordered pair in line. Perfect. And the next one. Open or closed?
Open.
Many students in their tests or quizzes or final exam, they stop at 1. Look what happens if you stop at 1. If you stop at 1, you omit all these values. Between 0 and 4, there are infinitely many values. Infinitely many real numbers. You cannot do that. You have to stop at 2 and leave it open. Okay, what about the other branch? Where does it start?
2, -1.
2, -1 indeed.
Close point.
And then 3, -2. This is indeed our function. Notice that the red or orange did not go to the right-hand side. It can't. And the second branch cannot go to the left. It can't. That's why I specifically said here, and I write it and write it and write it, between 2 and infinity, this is the function. Between negative infinity and 2, this is the function. And they cannot be combined or crossed or anything else. Do you think we can say now that we got the idea about how to graph these piecewise defined functions. Do you think we need more examples? Okay, we'll review more. So let's finish then with 8.4, and then we'll come back and review everything. Eight point four deals with, this is the last section for test 1. 8.4 deals with relationships between variables. It's called variation. There are 3 types, 1, 2, and 3. Type 1, direct. Type 2, inverse. And type 3, joint. What does this mean? Okay, so let's talk about the first one. Direct. Let's suppose in a word problem I am told, or I read this sentence. Y varies directly as x. I could be also told, that's another option, y is directly proportional with x. If I read this anywhere, or somebody tells me y varies directly as x, or y is directly proportional with x, this is what is the translation of these 2 sentences in math. Y equals k multiplied by x. K is a constant. It's called constant of proportionality. If, for example, I'm told the volume varies directly with temperature, I'm going to write V equals K times temperature, or it can be uppercase T, or it doesn't matter.
Can you slide up?
Yes.
Thank you.
So, as an example, so if I'm told y varies directly as x, or I'm told y is directly proportional with x, I get y equals kx. But I may be told anything else, like volume is directly proportional with temperature. Then I will be writing this. Okay? Let's look at a couple of problems with this relationship, and then we'll look at the other 2. On page 542, in case you have your books, yes, let's try number 11. It's something that we are confronted with all the time. The amount P of pollution varies directly with the population N of people. So they came up with a study, or they came up with a result from a study that says that the more people, which makes sense to me, more people, more pollution. So the quantity of pollution varies directly with the number of people in a city. Before I even read on, what does this mean? How do I translate this sentence in math? Number of pollution in whatever units varies directly with the number of people, as the number of people in a city. How do I translate this in math? Exactly. This is the relationship. And now I can read on. Let's read the second sentence. Kansas City has a population of 460,000 people. Population, 460,000 people. Okay? And produces about 270,000 tons of pollutants. 270,000 tons. And this is people. Now I'm going to say, let's stop for a moment and think. Why is this I didn't even read the rest of the problem, but why do you think this information is given to us?
So we can find the constant.
Exactly. Without this information, I cannot determine the constant, and I will not know the exact relationship. Once I have the constant, then I know exactly how these two are related. Not just directly, but the constant is such and such. Exactly. Thank you, Mike. So, I will write 270,000 equals K multiplied by 460,000. Of course, I'm going to divide both sides by 1,000. I'm sorry, by 10,000 actually. And then I'm going to divide both sides by 46. So the constant is this. I don't need to spend time on trying to find it in approximation. This is good enough. I'm fine. This is the constant, whatever it is. But I have to put it back in the equation. I determine the constant from the given information, and now I know for sure this is the relationship. P equals 27 over 46 multiplied by n. Now I can read on and see what they're asking me to do. Find how many tons of pollution we should expect St. Louis to produce if we know that its population is 319,000 people. Assuming the relationship is correct and is valid for all cities. Now we are asked about a different city, how many tons of pollutants it appears that it produces, according to the relationship we have. What do I have to do? Yes, multiply 27 by 319,000 and divide by 46. So P equals, I'll grab my calculator, I'll multiply 27, multiply by 319,000, and I divide everything by 46. I got 1,87239. 1,87239 tons of pollutants. I'm hoping that you are going to find this section the easiest of all. That's it. That's all we have to do. Second type of relationship between variables is inverse. I could be told, or I could read somewhere, one of the two options. Y varies inversely as x. Y varies inversely as x. Or I could be told y is inversely proportional with x. Regardless, one or the other, it doesn't matter. Coming back here for a second, what does this mean? It means that if x increases, y increases. If y decreases, x decreases. They go in the same direction. More people, more pollutant. The inverse is the other way around. One increases, the other one decreases. One decreases, the other one increases, right? So the relationship, the mathematical relationship cannot be on the same line, right? So it's going to be y equals k divided by x. If I increase x, I diminish y. If I decrease x, I increase y. Let's look at a problem. On the same page.
22.
Which one?
22.
Very good. Let's look at 22. On page 542. The weight of an object on or above the surface of Earth varies inversely as the square of the distance between the object and Earth's center. So let's read this one more time. Just this part. The weight, okay, I'm taking notes. That's what I want to denote it by. The weight of an object on or above the surface of Earth varies inversely as the square of the distance between the object and the Earth's center. I'm going to call the distance d. These are my variables. I wanted to denote them by W and D. You can use any notation, of course. There is no limitation to that. Okay. So I know now, in short, W varies inversely with the square of D. How do I present that in mathematical terms?
W equals K over D squared.
Exactly. That's it. Now I can read on. Excellent. Thank you, Jack. If a person weighs 160 pounds on Earth, if a person weighs 160 pounds on Earth, assume that the Earth radius is 4,000 miles, okay? If a person weighs 160 pounds on Earth's surface, find the individual's weight if he moves 200 miles above Earth. And we are told in parentheses, assume that Earth radius is 4,000 miles. So, if a person walks, remember D is the distance between where the person is on Earth or above, somewhere in the air, on a plane. So the distance is from where the person is to the center of the Earth. If we walk on Earth, then we find ourselves 4,000 miles away from the center of the Earth. So a person who walks on the Earth, it's somewhere outside in the parking lot, weighs 160 pounds, then that person is exactly approximately 4,000 miles away from the center of the Earth. Why is this information given to us? To find the constant, okay? So let's do that. So then I have 160 equals K divided by 4,000 squared. How do I determine K? Remember, this is nothing else but a proportion, or if you want, you multiply both sides by 4,000 squared. So K equals 160 multiplied by 4,000 squared. So 4 squared is 16, and multiply by 16, it's 256. And I have 3 zeros, another 3 zeros because it's squared, and another one. So 256, 1, 2, 3, 1, 2, 3, and 1. So therefore K, so the equation is, the relationship is W equals 2,560,000,000 divided by the distance squared. Now we can read the question. And now we can answer the question because we have the exact relationship. Where is the question? If a person weighs 100, find the individual's weight if he moves 200 miles above. So the person is not walking on the parking lot now, he's 200 miles up in the air. So what is the distance between that person and the center of the Earth now? It's 4,200. So now we want to see how much is that person going to weigh up there, because when he finds himself at 4,200 miles away from the center of the Earth. So then W equals over 4,200 squared. That will be his weight. Do you think it's going to weigh less or more? Less, of course. Tell me what you get. I got 145.13. No, 4.12. Now you can say, if somebody asks you, how much do you weigh, you can say 100 pounds. And they say no. And you can say, yeah, when I'm up there at 200 or 400 miles away from the surface of the earth, I do weigh 100 pounds. Any questions on this? Okay, last type 3. Joint. This is the type of relationship that involves more than 2 variables. As you've noticed, I'm sure, direct involves 2 variables. Although we can have combinations. But direct involves 2 variables. Inverse involves 2 variables, x and y. K is a constant. Now, joint involves 3 variables. So I can read a sentence like this, or somebody can tell me this. Y varies jointly as x and z. If I'm told or I read something like this in mathematical terms, I would write y equals k times x times z. So let's look at an example with joint variation. Yeah, let's look at 40. On page 543, let's read the problem. The number of cars manufactured on an assembly line at a General Motors plant varies jointly as the number of workers and the time they work. Okay, so let's think. The number of cars, I'm going to call it by C, denoted by C, manufactured on an assembly line at a General Motors plant varies jointly as the number of workers. I'm going to call them W. And the time they work, I'm going to call it T. You can come up with any variables you want. So I'm going to say C is cars, W workers, T is time. So the problem says, one more time, the number of cars, so C varies jointly as the number of, or C varies jointly as W and T. What do I write? Which mathematical equation or which equation will model this situation? Very good. Now I can read on. If 200 workers can produce 60 cars in 2 hours, why is this information given? To find the constant, so then 60 equals k times 200 and times 2. It turns out that k equals 60 divided by 400. Of course, I'll simplify. I'll simplify by 10, and I'll simplify by 2. So k equals 3 over 20. This will not help if I don't go back and write the new equation, or the actual equation. C equals 3 divided by 20, WT. And now I can read on and try to answer the question. Find how many cars 240 workers will produce, should be able to make in 3 hours. How many cars 240 workers will be able to produce in 3 hours? What do I do? Oh, what am I doing? This is 20. So 3 divided by 20, multiply by 240, multiply by 3, and tell me what you get. Say it again. 180? 108. Very good. So I don't have to do anything. Thank you. So C is 108 cars. What did you say, Becky? Okay. Good. This is the end of everything we needed to cover for test 1. So I would like now to go to the end of chapter 8, the review section that starts on page 547. And then I would like to go back to the end of chapter 4, because that's what we have mainly, and also talk about more inequalities. Okay? So on page 547, we are reviewing chapter 8 for our first test. Okay, so we can have word problems like we had on the previous quiz that I just returned. We can have graphing lines. We can have determining the equation of a line passing through 2 points, passing through a point and perpendicular to another line. Problems like these, and you tell me where to stop. We may have absolute value functions to graph. We may have radical functions to square root. We may have piecewise defined functions, and I can't think of anything else. And reading from a graph. What would you like to start with? Should I repeat what I just said? It was kind of quick. So word problems, like we had on the previous quiz, graphing lines, graphing absolute value, graphing the square root function, graphing piecewise defined functions, determining the equation of a line that passes through a point and is perpendicular or parallel to another line, and the relationships between variables. Any particular problem you would like to start with? If not, I will choose. Okay, I would like to start by graphing 43 on page 548. We're given f of x equals the square root of x minus 4. We're asked to graph this. And furthermore, I'm going to ask you not just to graph it, but also find the domain and range, of course. The domain is mandatory, but also find the range. Ready? The question of domain will always appear in some form or another in any of your tests. So, I'm looking at this function. First, I have to identify it. What type is it? Radical. Is it a friendly function? Normally, a radical function, is it friendly or not? No. So then I have to think, okay, it's radical, and then I have to write something because it's not friendly in order to find its domain. So what do I have to do? What do I have to write and solve in order to find its domain? Because that's my starting point. I can't graph before I find the domain.
X has to be greater than or equal to 0.
No, because x is not the... Exactly. X minus 4 must be greater or equal to 0. This quantity, everything I have under the square root, must be greater than or equal to 0. Excellent. So then from here I solve and I get x greater or equal to 4. So then the domain is clearly what? Excellent. So when I graph the function, I better graph it between 4 and infinity. Otherwise, I would be making a huge mistake. Okay, so in my chart, the table of ordered pairs, I will start with 4 and go to infinity. I will pick some ordered pair, some x values, something easy that I can easy plot. So what will that be? 4 is mandatory. 4 must be in the chart, and I have to plug it in. What do I get? 0. So please find the 2 other values such that I can easily take the square root from it. Now, if you say 6 for x, then I'll say 6 minus 4 is 2. And the square root of 2 is 1.41. Not very easy to plot. So come up with two other values that I can easily take the square root from. They're perfect squares, in other words.
That's one.
Too far. What about 5? Right? And what about 8? So let's plug in 5. What do we get? All the numbers are fine. Use any number you like that you come up with. So when x is 5, how much is y? And when x is 8, how much is y? 2. That's all I really need. But you can go far out as you want. Okay. First ordered pair from left to right, please.
4, 0.
And then 5, 1, 6, 7, 8, 2. And here it is. We have the domain, we have the graph, and this is our graph f of x, the square of x minus 4. And now I would like to ask you, what is the range of this function? Perfect, thank you. Good. Let's work on problem 55 now. Any questions on this? Yes, Becky?
About the line, 5 and 8.
5 minus 4 is 1. The square root of 1 is 1. 8 minus 4 is 4. The square root of 4 is 2. Better? Perfect. Problem 55. And we are asked to find the equation of a line passing through this point and perpendicular to a given equation or given line, this. What do I have to do first?
Add the slope and give it
Yes. So here's a scenario. I'm not really graphing the line, but here's a scenario. I want to determine the equation of this line, and I know two things about it. One thing is that it goes through this point, negative 5, 7. And the other thing is that it's perpendicular for 90-degree angles on this line. 5x minus 4y equals 10. So what do I do? Yes, I do have a point. This point is not the y-intercept. It's not 0 comma a number. So I will have to think of y minus y1 equals the slope times x minus x1. I have no choice. I do have a point, which is negative 5 comma 7, but I'm missing a very important piece of information. I'm missing the slope. So how do I continue?
solve that equation from there.
Why will I have to find the slope of this line, and how do I find the slope of this line? Yes, in order to find the slope of the unknown line. Yes, correct. So how do I do that? What do I have to do here in order to find its slope?
Y equals mx plus b.
Yes, I have to solve for y. So negative 4y equals negative 5x plus 10. All I did was I moved 5x to the other side, changing its sign. What next?
Divide by 4.
Negative 4, correct. So y equals 5/4 x minus 5/2. 10 over 4 is 5 over 2. Okay, so I solved the given equation for y because I wanted to find the slope of the given line. So I'm going to call this M2. So how much is M2 then? 5/4. Then I know M1 for sure, because their product has to be negative 1.
It's nitpicking, but shouldn't they go the other way? Because that's the negative. There's the one. M2.
So negative 5 over negative 4 is positive 5/4.
I mean, it's not too bad.
This one? Negative 4/5. That was correct. Negative 4/5. The product has to be negative 1. Do you want me to go back and check something?
No, it's not that at all. It's just the directions of the lines. Never mind.
The lines? Oh, remember I said I'm not graphing anything. I'm just graphing the idea. I did not know from the beginning whether this line will have a positive slope or a negative slope. I had no idea. Oh, I see what you mean. So no, I said I'm not graphing the lines. This is the idea. But you're right. This should have been this way. This should have been this way because the slope is negative. Good. So this is negative 4/5. So now we're ready to plug everything in. And then what? Distribute, combine like terms, and that's it. So then y minus 7 equals negative 4/5, x plus 5. Do we agree with this step? Good. So then I distribute negative 4/5, negative 4/5 x minus 4, and then I have to bring us positive 7. So this is y equals negative 4/5 x plus 3. What does this represent? It's the equation of the line that does what?
Passes through negative 5, 7, and perpendicular.
And perpendicular to the given line. Very good, excellent.